the triangle inequality is one of the most fundamental tools in analysis. Consider two complex numbers, or vectors, in the plane z and w. We can add them geometrically by placing the tail of w at the tip of z. The sum, z plus w, is the vector connecting the start to the end. The triangle inequality simply states that the length of this direct path, the absolute value of c plus w, is always less than or equal to the sum of the individual lengths. Equality only holds when z and w point in exactly the same direction. This is a very valuable tool that will come up frequently in our studies. We often need to estimate the distance between 2 points, say the absolute value of x minus y. But calculating this directly can be difficult. A standard trick is to introduce an intermediate point, z. By adding and subtracting z inside the modulus, effectively adding 0, we can split the problem into two manageable parts. This technique is essential for proving convergence of sequences, continuity of functions, among many other key results in mathematics. Sometimes, however, we need a lower bound. This is the reverse triangle inequality. We prove it using the standard version. We start by rewriting one vector as a sum involving the difference. Applying the standard triangle inequality allows us to split this sum. Rearranging the terms gives us one direction of the inequality. By symmetry, the exact same logic applies to the other variable, effectively bounding the quantity from both sides. Recall the definition of absolute value. Showing a value lies between negative m and positive m is equivalent to bounding its magnitude by m. We have just established exactly these conditions for the difference of norms. This completes the proof of the reverse triangle inequality. Geometrically, think about the gap between the lengths of two vectors. The third side must always be long enough to bridge this difference. As we can see, this minimum distance is achieved exactly when the vectors align, flattening the triangle. In any other configuration, the distance is strictly greater. To wrap up, the standard triangle inequality gives an essential upper bound, while the reverse version grants a rigorous lower bound.